So good evening. You just took the Chapter 5 test earlier today. I will hopefully be getting those back to you tomorrow, but possibly not until Wednesday. I'll be working on those. What we're doing now is we're going to look back through Chapter 2, and we're going to do a section on applications. Everything we've done in Chapter 5, is quadratic equations. And let's look at applications of quadratic equations when it comes to real-world things. The first thing that we want to do in this first example is to find the dimensions of the rectangle. I know that the area of the rectangle is 10 square feet. I know that the length is x and that the height is 3x minus 13. I want to find the value of x and then find the dimensions. So how do you start? Well, it's a rectangle. So how do you find the area? Why area? Because I'm given the area. Well, to find the area, it's base times height is equal to the area. The base, well, that's x. The height, well, that's 3x minus 13. That's equal to 10 feet squared. Scoot that over so we have a little more room. So base times height is equal to my area. That's the formula I'm going to use. There's lots of ways that I can solve this. If I try to distribute this out, I get 3x squared minus 13x is equal to 10. Subtract 10. 3x squared minus 13x minus 10 is equal to 0. At this point, I can try to use California method. What multiplies to be negative 30 and adds to be negative 13. 1 and 30 is not going to work. 10 and 3 comes close, but you're going to have a problem with negatives because negative times a negative is going to be positive 30. It's not going to give you negative 13. So I can't just factor this out. So instead of working with factoring, I want to try something different. Let's go ahead and solve this by graphing. And when we solve by graphing, I want to come back and I want to look at my original problem. The left part I'm going to call y1. The right part, I'm going to go ahead and call this y2. I'm going to pull up my handy dandy little calculator and I'm going to go into my y equals. And I'm going to plug in my y1, I said, was x times 3x minus 13. That's my x. My y1, my y2 was 10. Well, what's a good window for this? Well, the first one is going to give me a quadratic. I don't know exactly what it looks like. If I look at my second equation, y equals 10, I like my y, to be at least bigger than that. So let's make my y max 15. And so I'm going to go ahead and I'm going to graph this. There's my quadratic equation. There's my line. To find the solution to this, I want to actually find my intersection points. I want to find this point and this point. That's what I'm looking for. That's what I need to find. And so, that's what I need to look for. Find those intersection points. Now remember, if I had plugged in this equation, I would actually be looking for zeros where I cross the x-axis because it equals 0. Instead, however, I plugged in the original equation, base times height equals area, and this way I have to find my intersections. So I go back to my graphing calculator and I want to find my two intersections. To find intersections, I have to go to the calc button. So I hit second trace to get calc. Number 5 is intersection. So I'm going to hit enter for first curve, enter for second curve, enter for the guess. And my first intersection point, y equals 10. I knew that y would equal 10. That was part of my original equation over here. X is my solution. X is equal to negative 0.6 repeating, which is negative 2/3. That's my first answer. What's my other intersection point? Well, I'm going to hit second trace to go to calc again. Number 5 is intersection. I want to hit enter for first curve, enter for second curve. But for the guess, I have to arrow over right. So I'm closer to that second point. I'm going to hit enter. And I get my second intersection point. My second intersection point is now here. And that, it tells me, is x equals 5. So x is also equal to 5. Now, if I look at my original problem, I need to remember that I'm finding the area. I'm looking at lengths. So x equals negative 2/3 does not make sense for 2/3 to be a length. So my part of x equals negative 6 repeating, negative 2/3 doesn't work because it's a negative number. So my answer is going to be x is equal to 5. Now that's not my final answer because it actually asks for the length of the two sides, my dimensions. So my base is 5 feet, and my height is 3 times 5 minus 13, which is, okay, I give away the answer. 3 times 5 minus 13, which is 15 minus 13, which is 2 feet. So my dimensions are 5 feet by 2 feet, which multiplies to be 10 feet. And I get that by plugging in x equals 5. There's my first possibility of a type of question I might have in this section. Second question. Let's go ahead and minimize my recorder. A border problem. You have made a rectangular stained glass window that is 2 feet by 4 feet. So I'm going to go ahead and I am going to create a rectangle, which is, believe it or not very, but close to 2 feet by, try that again. Try that again. 2 feet by 4 feet. One more time. 4 feet. You have 7 square feet of clear glass to create a border of uniform width around the window. How wide should the border be? So I'm going to go ahead and get a second rectangle, and I'm going to put it as a border around my first rectangle. That's what it's asking me to do. And since you're melting the glass, I can make it uniform, but I just need to know what this length, this uniform length, needs to be. I don't know what it is, so I'm going to call it x. Since it's uniform, it's going to be the same dimension all the way around, x by x by x by x. Now, at this point, I need to kind of figure out how I'm going to come up with an equation to solve this. And I need to look at a couple different things. The first thing I need to do is figure out what I want to use. Since it tells me I have 7, let's try that again. Since it tells me I have 7 square feet of clear glass, it'd be nice if I could talk about area because it's 7 square feet. And that's the only dimensions I have on this outside part, is this adds up to 7 square feet. And I need to know what this clear glass is, how much of this I have, how much to use. I need to use that 7 square feet. Since it's in square feet, I want to use area. So just on the last one, since it's a rectangle, I'm going to say base times height is equal to my area. I know the black squiggly part has an area of 7 feet, 7 square feet. I know that the inner stained glass part is 2 feet by 4 feet. Multiply that, and that's going to be 8 square feet. So my area is going to be 15 square feet. At this point, what I need to do is I need to find my base and my height. If I look at my base, I can look across here and I can see that this length from here to here is going to be x units long. My length from here, let's make this a different color, from this center point to here I already know is 2 feet. And my length, my last length, starting here and going to the end, I again know is x feet. So my base is actually x plus 2 plus x, or 2x plus 2. Well, what about my height? If my base is 2x plus 2, my height, again, it starts here, and it's going to meander down to here, and I know that that's x. From this center area on down to here, I know that this is 4 feet. And lastly, I know starting from there and going to the end, again, I know that this is x again, using both these x's. And I here get x plus 4 plus x, so I get 2x plus 4 as my height. So I can plug these two into my equation for my base and my height. And I can say, well, I have 2x plus 2 times 2x plus 4, and that's equal to 15. There's my equation. I have an equation with one variable. If I FOIL this out, it will be a quadratic, and I could try to factor it out. But I'm going to go ahead and, again, use my calculator. I'm going to go back to my calculator. I'm going to clear this out. I'm going to go back to y equals and clear out my y1 and my y2. I'm going to plug in my y1 as parenthesis 2x plus 2, close parenthesis, open parenthesis, 2x x plus 4, close parenthesis, hit enter. My y2, I'm going to plug in the right side, which is 15. So what I just did, if I look back at this formula, this left side is y1, the right side, again, is y2. I plug that into my calculator. Looking at my dimensions for this, I have that 15, so I need to make my y max greater than 15 so I can see that. So let's make it 20, and I'm going to hit graph. Again, since I didn't solve this to equal 0, what I'm going to be looking for on this graph, just like on the last one, are my intersection points, the one on the left and the one on the right. Just like on the one that we just talked about, the one on the right is going to be real. The one on the left is going to be imaginary. So I'm going to want the green intersection point. Even though I'm going to find both, I need to remember I need a real value, and I also need a positive value. So I'm going to go back to my calculator. I'm going to hit second trace to go to count. I want number 5 intersection. First curve, enter. Second curve, enter. Guess, enter. And it gives me the intersection is 0.515. That 15 is constant. So I know that x is equal to 0.5 feet. Yes, I'm the math teacher. I'm going to find the other intersection point. So I'm going to hit second trace to go to calc. Number 5 is intersection. First curve, enter. Second curve, enter. I'm going to arrow over so I'm closer to the other point. I'm going to hit enter, and I get negative 3.5. So x is also equal to negative 3.5 feet. But I can't have negative feet, so the answer is the one in blue. X equals 0.5 feet. Let's check to see what the question really was. How wide should the border be? The border should be 0.5 feet or 6 inches wide. That's how I solve this kind of a problem. I need to set it up into so those are two types of problems I can have. We had the border question and we had the area question, and both of these did use area. We do have a third example, a third type of question we might have. So let's look at this. This is example 3, maximizing revenue. Here I'm not looking for intersection points, I'm looking for the maximum, the most, the highest. And most probably we're going to be looking for the vertex. At the same time, we might be looking for a minimum value. Maximizing and minimizing means to find the vertex, and the way to find that is similar using the calculator. So let's look through this and see what this tells me. Example 3, maximizing revenue problem. You maintain a website that allows subscribers to download audio and video clips from their favorite bands. When the subscription price is $16 per year, you get 30,000 subscribers. For every $2 increase in price, you expect to lose 1,000 subscribers. How much should you charge in order to maximize your annual revenue? What is your maximum revenue? This problem is very, very close to what Netflix had to do. They changed their price, understanding they were going to use subscribers, not because just they could, but they felt they could maximize their revenue, make the most money by raising their price, understanding they would lose subscribers. So how do I make this into a problem? I need to remember that cost times number of customers is going to equal my revenue, my money. Okay? I want to maximize my revenue, make this number as the largest that it can be. So I need to look at how this is working. Right now, I have an equation that tells me my cost is $16. My number of customers is 30,000 customers. So my current revenue is going to be $480,000. That's how this formula works. But I'm changing it up because I'm not just doing $16. I'm going to do $16 plus 2 times X. X in this scenario is the number of times I'm going to increment, or I'm going to change my price. So every time I go up $2, that's 1 increment. So from 16 to 18 is 1 increment. 16 to 20 is 2 increments, because 2 times 2 is 4. 16 to 24, well, that's a difference of 8. So that's 4 increments. And that's kind of how it works. Because of this $2 increase, each $2 is 1 increment. So that 16 plus 2x, that's going to be the amount of money I'm going to charge. And how many increments I need to go up is x. Using that same incrementing thing, I'm going to start with 30,000 subscribers, and I'm going to lose 1,000 of them per increment. Every time I change by $2, I'm going to lose 1,000 subscribers. So that's my cost and my number of customers. And they're both in terms of my increments, the amount we're counting of X. That's going to equal Y, my revenue. And I want to maximize this revenue. I want to make it as large as possible. I have my current revenue. I have my maximum revenue. Let's go to my calculator. I have an equation. Notice how this is different. There's my word notice. I don't have a number over here in Y like I was doing in the last one, where it was an area of 10 or I had an area of 15. Here, I don't know a number for Y. I need to find the largest Y. Yes. After 3 interruptions, let's go ahead and continue. So I have to go to my calculator. I'm going to hit Y equals. My first equation is going to be, let's clear these out. I'm only going to have 10. Okay, let's try this one more time. So I'm going to plug in my equation. I only need one equation this time. I have my cost, which is $16 plus $2 for every increment I increase, and that's going to be multiplied by my number of customers, which is 30,000, minus 1,000 for every increment, which is my X. Okay, So that's my first equation, 30,000, 16 plus 2x times 30,000 minus 1,000x. If I graph this right now, I'm going to get absolutely or very little because I'm way too small. Think about this. My first current revenue is $480,000. That's my Y. So I need to make my Y in my window huge. 480,000, let's make it, I don't know, 800,000. My X, thinking 10 is going to work is kind of silly, so I'm going to go ahead and make it 40, just to make it bigger. If I graph this, notice now I get a maximum point. Since I want to maximize my information, I want to find this point up here, my maximum. So I'm going to go back to my calculator, and I'm going to go back to the calc by hitting second trace. Number 4 is my maximum. And to do this, you need to left arrow over to where I am left, where it asks for a left bound. I want to be left of the maximum, and hit enter. It asks for a right bound, so I'm going to arrow over to right of the maximum, and I'm going to hit enter. I guess I'm going to go to the middle someplace and hit enter, and it maximizes it for me. And notice the maximized graph tells me two things. It tells me my number of increments, and it tells me my maximum revenue. This tells me that if X is equal to 11, if I have 11 increments, my maximum revenue, the most I can make selling my music, is going to be $722,000. That's the most money I can make. I can maximize that by selling $722,000. How many times do I have to increase more than I have? Well, let's look at this. So number X equals 11, that's the number of times I have to change the price. So if I plug that into my cost, 16 plus 2 times 11 tells me that 16 plus 22, that's $38. I can charge $38 a year to maximize my cost. But when I do that, I have to take this 30,000 and subtract 1,000 times 11, and I'm going to get 30,000 minus 11,000, which is 19,000 subscribers. So that tells me if I charge $38 a year, I will reduce my subscribers to 19,000 subscribers, but I'm going to maximize and make the most money I can at $722,000. This was the goal of Netflix over this last summer. Was it something that really worked for them? I'm not sure, but this is the type of process they went through to come up with their price change. That's the last of the notes. We'll cover more of this in class tomorrow. Have a great day.